Hey, it's Miss Phelps, and today we're going to be talking about quadrilaterals. Now, we've talked about quadrilaterals a little bit before, so I just want to take a few minutes to recap about a few things, and then we're going to get into some new stuff. Now, first of all, just to refresh your memory, I want to just go back over the properties of convex quadrilaterals. Remember, there are two types of polygons. One kind is convex and the other is concave. Convex are the normal ones that we use, where the sides, if you extend the sides, they never go back into the polygon. And then there's concave, and they're the ones, if you extend the sides, that they go inside the polygon. Alright, so we're going to be talking about convex ones tonight, and we've talked about those before. But for quadrilateral, they contain 4 sides and 4 vertices or angles. And they have to add up to 360 degrees for their angles. Remember, they make, if you draw a line from one vertex to, as many others as you could to make triangles, you'd only be able to make 2 triangles in there, and each one is 180 degrees. So together those make 360. Alright, so quadrilaterals are normally classified by the number of parallel sides they contain. So the first one I want to start with is called a trapezium. And a trapezium is a quadrilateral with no pairs of parallel sides. I've got an example here on the right. None of the sides are parallel and none of the angles are congruent either. Now, the next kind that is a type of trapezium that you are familiar with is a kite. It has 2 congruent pairs of adjacent sides, but if you notice, they're not parallel lines, they're not parallel sides, but they're adjacent parallel sides. So these top 2 are parallel and the bottom 2 are parallel. And one of their property is that their diagonals are perpendicular. And the other property is that one diagonal bisects the other one. So this one comes straight down like this other one comes across, and the one that's coming across will be bisected by the long one. Alright, the next thing I want to talk about is a trapezoid. Now this one you are more familiar with, I'm sure. A trapezoid is a quadrilateral with only one pair of parallel sides. Now, I know you've seen it another way, but I wanted to show you this way on the right, because this is also a trapezoid. This top line and this bottom line going across are parallel, and then it has 2 other lines that connect it. So there's only one set of parallel sides. Now, the one on my left is an isosceles trapezoid. This is the one that you see most of the time. And an isosceles trapezoid has non-parallel legs that are congruent. So this left side is the exact same amount as this right side is. And their base angles are congruent. So let's say, for instance, this one down here is, let's say 60. Then this one over here is also 60. Alright. The next one is a parallelogram. And it is a quadrilateral with 2 pairs of parallel sides. Its properties are that opposite sides are congruent and opposite angles are congruent. We talked about this one the other day in class, and if you remember, we also said that consecutive angles are supplementary. And this goes back to when we were talking about transformations, that these 2 parallel lines are actually being cut by transversal. So these 2 are consecutive interior angles, and that makes them supplementary. And we also said that opposite angles here and here are congruent. And remember, the diagonals bisect each other. So if from the middle to this end is 14, then from the middle to that end is also 14. Now these 2 along the left to the, well, they're both left to the right, but this one, let's say it's 20 centimeters. Then from the middle, oops, sorry, took off with my line. Then from the middle to this side is also 20 centimeters. So they're both bisected, but that does not mean they're all four congruent. Alright, the next one is a rectangle, and it's a parallelogram with four right angles. And its property is that diagonals are congruent. So this one is, unlike this one up here, if this is 10 and from here to here is 10, then this one up here to the middle and from the middle to the bottom is also 10 and 10. So they are congruent. Alright, next is a rhombus. A rhombus, unlike a rectangle, does not have right angles, but it does have congruent sides. So all its sides are the same. On a rectangle, all the angles are the same. And its property is that diagonals are perpendicular to each other. So around this, where the perpendiculars meet, where the diagonals meet, they form perpendicular lines. Alright, the last one, and probably the most familiar one to you, is a square. A square is a parallelogram with four right angles and four congruent sides. And its properties is that it has all the properties of a rectangle and a rhombus, because technically it is both a rectangle and a rhombus. Now, so that goes back to that phrase that people always say, a square is a rectangle, but a rectangle is not always a square. Well, that's true. A square is also a rhombus, but a rhombus is not always a square. So you have to be really careful, and you really need to learn these properties for each one. Make sure you bring your page back tomorrow, because I want to add a few things to it to show what's parallel and what's perpendicular and what's congruent. So I hope you have a great evening. Make good choices, and I will see you back at school.